We are back for some gas stoichiometry. So we're still going from substance A to B. We have to do that in our mole to mole. But now we are looking at this volume piece. Well, if we have 1 mole of any gas at standard temperature and pressure, which is 0 degrees Celsius and 1 atmosphere, we have 22.4 liters of a gas. Well, we also need to know about doing these conversions when we are not at STP. We have a little rhyme to remember that. If not at STP, use PV equals nRT. So let's go start checking out some examples. Our first example here, we have 0.5 liters of hydrogen gas reacting with excess oxygen at STP according to the balanced chemical equation here, and we are looking for the volume of water produced. So we're given hydrogen, we're looking for water. This is stoichiometry. Well, to do stoichiometry, we're going to have to take our given, which we always start with, and get to moles. Well, we just saw that little conversion factor that you might have already remembered to get from liters to mole when at STP. That makes it really easy. Every time we're at STP, 1 mole of any gas, it does not matter what gas it is, has a volume of 22.4 liters. Well, now that we're in moles, we get to do our actual stoichiometry, that mole to mole ratio. Just a quick 2 to 2, and then it asks for volume of water, so we need to get back out to liters. We're still at STP. So as you look at this, we might notice something a little wonky about our math. 22.4 liters on top and on bottom. Those just cancel out. Our 2 over 2 is going to go ahead and cancel out as well, leaving us with 0.5 liters of water that is produced. Well, since those 22.4s just cancel out, we don't technically need to do stoichiometry in mole to mole if we're going from liter to liter at STP. We have a shortcut way that we can do this. We can actually use a liter to liter conversion. If you realize that you have a stoichiometry problem that is liter to liter at STP, we can do this little shortcut where we are just using this liter to liter conversion. If you choose to use this shortcut, the only work you need to show is what is in this blue box here. It is important to note that this only works for liter to liter. If it asked you for grams or something, we'd still have to go to moles so we could then use molar mass. We won't have that canceling out situation like we do with liter to liter. Another fun thing about this is it actually works anytime you have constant temperature and pressure. That means that your reactants and your products are at the same temperature and pressure the whole time. Let's talk real quick about why that is. If they are at the same temperature and pressure throughout the entire reaction, we still have a proportional volume to 1 mole. It's just not going to be 22.4 anymore. If it is hotter, this number will get bigger, and if it is smaller, the number will get if it's cooler, the number will get smaller. But regardless, it's still going to be the same number, just not 22.4, and it's still going to cancel out. So let's take a look at a couple more gas problems now when we are not at STP. Okay, so here on 4, we're looking for grams of carbon reacting if 543 liters of carbon monoxide can be produced at this temperature and pressure here. That is not STP, so you should always have that little light bulb going off. Not at STP, use PV equals nRT. And we have our balanced chemical equation. So here, our given is this 543 liters of carbon monoxide. Well, to do stoichiometry, we have to get from liters to moles. Well, going from liters to moles, again, not at STP, we need to use PV equals nRT. So using that will get us to our moles of carbon monoxide. A couple things to note here. Our units of pressure are in atmospheres, so we need to be using that 0.08206 R in atmospheres. Don't forget to change your temperature to Kelvin every single time we are working with gases. Last thing to note, this is not our stoichiometry step. This is just getting us from liters to carbon monoxide to moles still of carbon monoxide. We have not gotten to carbon yet. We got to moles. Now we can finish out the rest of our stoichiometry going into that mole to mole ratio. 2-to-2 ratio there. Use our molar mass of carbon to get to our grams, and we find that we have 65.5 grams of carbon. 3 sig figs was our least number of sig figs with everything here, so that's what we kept. We're going to take a look at one more problem. Here, go ahead and pause the video, see how far we get on this, try out this little gas stoich on your own, and resume when you're ready to check your work. Okay, so we're starting with that given. As always, it's grams. We're switching between two chemicals, so we have to get to moles first. Then once we're in moles, we're using our mole to mole ratio from the balanced chemical equation. Well, it asks us for the volume of nitrogen gas, and we are not at STP. So once I get to moles of nitrogen gas, to find its volume, I have to use PV equals nRT since we are not at STP. So we get moles of nitrogen gas, we stop and solve, then we can go into our ideal gas law. Plugging in those moles of nitrogen, we'll be able to solve for the volume of 36.7 liters, 3 sig figs there. So there you have our second part of gas stoichiometry. One more to come next time.